Welcome back to Turtles All the Way Down. This video is the second part in our investigation into what scientific evidence we currently have for extraterrestrial life and intelligence. In the previous video, we discussed what we know so far about biosignatures from our inner solar system, from the planets Venus and Mars. In this video, we continue working our way to the outer solar system and beyond, to exoplanets. Farther out in our solar system to the large gas and ice giant planets, we find ourselves around the frigid environments of Jupiter, Saturn, Uranus, and Neptune. Orbiting these massive planets are some large moons that may, just may, harbor life. Even though there has not yet been any evidence of any biosignatures from these worlds, they do have characteristics that may make them habitable. First stop is Europa, the large icy moon of Jupiter. This world is filled with water, both icy and liquid. Its surface crust is cracked and quite young. A little smaller than Earth's moon, Europa's surface is the smoothest of all solar system objects. The constant flexing of its entire body due to its orbit around Jupiter causes internal frictional heat that warms its interior. As a result, a massive liquid water ocean exists below its solid, icy surface. This ocean averages more than 20 times deeper than any of Earth's oceans. 20 times deeper. The surface features long, crisscrossing fracture lines called lineae, where warmer water has evaporated out from within and deposited a brownish chemical on the surface. The composition is still a mystery, but it may be organic precursors to biology called tholins. Does life exist under the surface of Europa inside these vast oceans? It is a distinct possibility. And if so, how far has it evolved? How advanced is it? Single cellular? Multicellular? Or something else altogether? Other moons of Jupiter are known or suspected of consisting of subsurface liquid water oceans as well. These include the larger moons Ganymede and Callisto. However, these moons have not had as much tectonic movement of their icy surfaces due to less internal heat as Europa has, and therefore may not be as immediately attractive targets for searching for biosignatures as Europa is. NASA plans to investigate Europa in more detail soon, with the Europa Clipper mission set to launch later this year and arrive over Europa in 2030. And there is the European Space Agency's Jupiter Icy Moon Explorer mission launched in 2023 and will arrive in 2031 to study Europa, Ganymede, and Callisto. I say Godspeed to these missions. They're going to be exciting to watch. Moving much farther out to the next planet, the great ringed giant Saturn, we find another strange moon. Titan is the largest moon of Saturn, and behind Ganymede is the second largest moon in our solar system. It is the only moon with a dense atmosphere. The atmosphere is mainly nitrogen, but also has clouds of methane and ethane, and an orange haze of organics. The surface has seas, lakes, and rivers of methane, water and ammonia volcanoes, and sand dunes. In 2005, NASA's Cassini mission launched its Huygens probe on the surface of Titan. This is the real-time footage of the landing from the probe. And this was the image taken from its surface. Under the surface may hide liquid or icy water oceans. Many of the conditions of Titan are similar to what astrobiologists believe the Earth was like in its earlier years, as life was getting its start. It also has unique conditions that may make it suitable for bizarre forms of life that use methane and other exotic hydrocarbons. As of yet, Titan has not had any biosignatures that have been detected. Still, Titan is a very attractive target for future missions to investigate for these signatures. One is NASA's Dragonfly mission, which is planned to launch in July 2028 and arrive at Titan in 2034. It will be a rotorcraft drone that will fly to different locations and help research the habitability of the moon and its prebiotic chemistry. Another exciting mission to keep your eyes on. Recently, another intriguing moon of Saturn's, Enceladus, has many astrobiologists excited. One of the most fascinating features of Enceladus are the recently discovered water plumes spewing from its surface. These are potential targets for sampling, as they consist of the actual water from beneath the surface ice and may contain biosignatures within. The structure and surfaces of both Europa and Enceladus are similar. Tectonic activity on the surface has been found with water ice cracks and linear spreading zones along with liquid water oceans underneath. However, again, no known biosignatures found here as of yet. Future missions to both land and to orbit the moon and sample the water plumes of Enceladus have been proposed and are under development. Many other solar system worlds may contain water on or within their surfaces. These consist of the dwarf planet Ceres in the asteroid belt, Saturn's other moons, Dione, Tethys, Rhea, and Iapetus, Neptune's moon Triton, Uranus's moons Umbriel, Oberon, and Titania. Then there is the dwarf planet Pluto and its large moon Charon. Let's exit our solar system altogether and enter interstellar space. As of the creation of this video, at the beginning of 2024, there appears to be only one example of a possible biosignature found outside of our solar system. 120 light-years away from Earth is a cool dwarf star named K2-18. Orbiting it is a large rocky exoplanet almost 9 times as massive as Earth, named K2-18b. It orbits around its star in the habitable zone where liquid water can exist on its surface. Using the James Webb Space Telescope, an exoplanet's atmosphere can be analyzed. The innovative technique that is used to determine the chemical composition of an exoplanet is by examining the short time in which the parent star's light passes through the planet's atmosphere as the planet moves in front of the star, then comparing that with the light spectrum from the star itself. The differences are the fingerprints of the planet's atmospheric gases absorbing the star's light. Every chemical has a unique spectrum that identifies it. What was found around K2-18b? The James Webb Telescope found an abundance of hydrogen along with methane, carbon dioxide, and dimethyl sulfide in its atmosphere. The mass and location of the planet and the fact that it has held on to its hydrogen means that this is the first Hycean exoplanet ever found. What is a Hycean planet? It is a large, Neptune-sized rocky planet with a hydrogen atmosphere and a liquid ocean on its surface. Not only is this a great discovery in its own right, but the actual chemical detection of dimethyl sulfide in its atmosphere is a startling surprise for astrobiologists. Why is that? Dimethyl sulfide is a biosignature. On Earth, it is exclusively a metabolic byproduct of ocean phytoplankton. However, the dimethyl sulfide signal detected in the atmosphere of K2-18b is weak and needs to be examined with higher resolution. But if it's confirmed, does this mean that we are seeing the products of real biology on that planet? Well, maybe. The truth is that we will need other pieces of independent biosignatures to confirm that possibility. It may be that the dimethyl sulfide is somehow being produced by non-biological chemical reactions on the planet that we are not yet aware of. While tantalizing, the signal is not a sufficient piece of data to clinch the case for extraterrestrials. We need more. What does make this exciting is the fact that we are just beginning to use this exoplanetary atmospheric technique and have already found a surprising biosignature. This bodes very well for the field of astrobiology, as this may be suggesting that these kinds of signatures are very commonplace throughout the cosmos. Other kinds of atmospheric biosignatures that astrobiologists have hypothesized could be searched for in atmospheres are out-of-place abundances of other chemicals. This is called thermodynamic disequilibrium. For example, methane in Earth's atmosphere would naturally be at a much lower level than what it currently is if there was no life here. However, life on Earth produces massive amounts of methane, and so it is found in overabundance. This is an atmospheric biosignature for Earth. This field of research is still quite young, but has a lot of potential in the search for life in the universe. This video, and the last in this series, which you can find here, summarized all of the data that science currently has about biological aliens or extraterrestrial biosignatures. Admittedly, it isn't a slam dunk by any measure, but what we do have is tantalizing and suggestive. The good news is that the search is only beginning and is ramping up with ever more experiments, probes, and attention. Personally, I think it is only a matter of time before we find convincing and conclusive evidence for extraterrestrial biosignatures. I eagerly await that day. We, the life on Earth, are a part of the natural processes of the universe. I strongly feel that those processes are not unique to this particular spot in the cosmos. We find much of prebiotic chemistry that worked here on Earth spread throughout the environments of space. However, biosignatures are not the only way to look for extraterrestrials. There is another way. That is, to look for the products of its intelligence. The next series of videos will investigate what science currently has with respect to technosignatures in our universe. Do they exist? Stay tuned for that exciting front in turtles all the way down. Thanks for staying with us, and make sure you subscribe to this channel so you can be updated on new discussions. Until then, bye for now.